Hi guys, this is Nuclear Aphrodite. Hope you're doing very well. Today we'll be flying the AV-88 B Harrier, and DCS World as of today has released a 14-hour trial of this aircraft. So I will just be demonstrating the Harrier's cold start procedure in this training video. So there will be an instructor and whose voiceover will be guiding through the video tutorial. So I will be speaking less and that pilot will be speaking more. So let's listen to the instructor and let's review the aircraft. So let's begin, guys. This is AV-88 B Harrier. Short takeoff and vertical takeoff landing
Welcome to the
aircraft.
first training mission for the RASBAM AV-8B Harrier night attack aircraft. In this tutorial, we will go through the before engine start checklist, explaining the main functions of the system. Throughout the training, you will be required to press spacebar to indicate that you are ready to proceed to the next step. The instructions will be visible on the screen until you do so. You can take as much time as you want at each phase. Let me know when you're ready to begin. The AV-8B Harrier night attack aircraft is a transonic, day and night, tactical ground attack fighter built by McDonnell Douglas Aerospace. It entered service with the United States Marine Corps in 1991 and is still in service today. The Harrier features high shoulder-mounted swept wings with leading-edge root extensions, or lurks, and automatic maneuvering flaps that aid maneuverability at high angles of attack. The aircraft has overall positive dihedral, aerodynamic, and high lift characteristics, enabling it to carry a deadly array of general-purpose and precision-guided munitions on its 7 external stations. The Harrier has 7 internal fuel tanks with a capacity of 7,759 pounds of fuel, and its range and endurance can be increased with the addition of up to 4 external wing tanks and or the use of probe and drogue aerial refueling. The aircraft is powered by a Rolls-Royce F402 RR408B Pegasus non-afterburning turbofan engine that provides 22,200 pounds of dry thrust. The F402 engine also has thrust vectoring exhaust nozzles that enable the aircraft to perform its signature vertical or short takeoffs and landings at sea or forward bases close to the front lines. A water injection system used for heavy VTOL operations lowers the jet pipe temperature and increases the thrust, for a short period of time, to up to 23,400 pounds. Flight controls are hydraulically powered to provide the desired effects throughout the Harrier's speed range, and a reaction control system, or RCS, diverts engine bleed air through the nose, wing, and aft puffer vents for attitude authority and jetboard flight. The cockpit is divided into 3 major areas. The left console, from aft to fore, contains the oxygen monitor panel, fuel shutoff handle, pilot services panel, external lights panel, exterior lights master switch, fuel panel, throttle quadrant, stability augmentation attitude hold system, or SAS, and trim panel. The main instrument panel, looking from left to right.
Alright guys, before I fly this aircraft, I also have to set its access command. So here is the tuning of the access so that the aircraft performs well during flight. Here's the pitch, here's the roll. Okay, the pitch and the roll is set. Rudder is clear. Thrust is clear. And we are good to go.
Right contains the landing gear flaps control panel, the combat water panel, the armament control panel, the master armament panel, the left and right multi-purpose color displays, the option display unit, ODU, the heads-up display, HUD, the upfront control, UFC, and HUD control panel, standby flight instruments and indicators, the FLIR power panel, miscellaneous power switch, the circuit breaker panel, the warning lights panel, the engine display panel, the fuel quantity indicator, the electronic countermeasures or ECM panel, the clock, and the brake and hydraulic pressure indicators. The right console, from fore to aft, contains the electrical panel, the VHF-UHF radio set control, the auxiliary communication, navigation, identification panel, or ACNIP, the interior lights control panel, the environmental control panel, the NVG stowage compartment and video recorder, and the ground power panel. The aircraft should be pre-configured by the plane captain prior to entering the cockpit, but it is important to conduct your own pre-start checks. These checks are performed in a left-to-right flow, beginning with the DEX enable switch. DEX enable switch should be set to off. DEX stands for Digital Engine Control System and is responsible for proper functioning of the engine.
Okay, so I have to turn the digital engine control system to off, which is off. Now I have to press the space bar.
Make sure that the fuel shutoff handle is also set to off at this stage. In this position, the fuel system is completely isolated from the engine.
Okay, so I have to turn this off as well. Okay.
Move forward to the pilot services panel and verify that the engine RPM select switch is set to low, indicating the low pressure fan RPM on the engine display panel. Selecting high displays the high pressure compressor RPM.
Okay, so the switch is set to low already.
Now set the engine fuel control or EFC switch to position 2. This switch determines which digital engine control unit or DECU will control the fuel metering unit responsible for the correct fuel flow into the engine.
Okay, so I have to set this to position 2. This is already set to position 2.
Next step is to verify that the Lift Improvement Device System, or LIDS, is in norm position. LIDS is a retractable fence that, when deployed, increases the vertical lift by directing the hot jet stream energy. It is part of your landing gear system.
Okay, so it is also in norm position. Fine.
Good. Now check that the oxygen switch is set to off. This switch controls the operation of OBOX, or Onboard Oxygen Generating System.
Okay, so this has also been turned off. Thank you very much, instructor.
Let's move to the H2o Dump Switch and make sure it is set to off. As the name implies, you'll want to use it to empty the 500-pound tank of distilled demineralized water. Water injection allows you to temporarily increase the engine RPM during takeoffs and landings.
Alright, so this is also turned off. That's very great.
Moving to the external lights panel, ensure the formation, position, anti-collision, and auxiliary landing light switches are set to off.
Okay, so all of them have been switched off already. Auxiliary light, anti-collision light, position bright light, formation lights are off.
Verify that the air refueling switch is in the in position. This pressurizes the fuel transfer system, transferring fuel to each center tank in series from all tanks in the group at the same rate that the fuel is being consumed from each group.
Okay, so this is also in position.
The left and right dump switches should be set to norm. This powers the left and right fuel jettison valve motors.
So this is also, both of them are in valve position, are norm.
Now ensure the left and right pump switches are set to norm. These energize the left and right AC boost pump relays located in the lower portion of each center feed tank.
Okay, instructor, so this has been switched to normal.
Check that the fuel flow proportioner is set to on. This powers the fuel flow proportioner, ensuring equalized flow of fuel to the engine between the Harrier's two feed groups.
Okay, so this has also been turned on right now.
Next, ensure the throttle is fully aft in the off or idle cutoff position.
Throttle is in the full idle. Throttle is full in the idle cutoff position.
Verify that the jet pipe temperature limiter is set to on. This ensures that the DEX JPT limiter function is not muted. The JPT limiter uses thermocouples in the turbine exhaust sample gas temperature to limit the RPM in different configurations.
Okay, so I have to turn this on, and this JPTL is on.
Now ensure that the manual fuel switch is set to off. The manual fuel system provides an alternate means of control if the primary fuel control system fails. It directly controls engine RPM and contains no automatic compensation, controls, or limiters. In the off position, engine control is performed by the decks.
Okay, so it's off.
Ensure the parking brake is aft in the on position. The parking brake applies approximately 3 hours of brake pressure in the system and prevents the throttle lever from moving past it while the lock is engaged.
Okay.
On the stability augmentation and attitude hold system panel, set the pitch, roll, and yaw stability augmentation system switches to on.
Okay. All of them pitch, roll, and yaw have been turned to on.
Set Q field to the on or Q field position. Q field provides artificial longitudinal force feedback due to the primary flight controls being entirely hydraulically powered.
Okay. So it is also on.
Set alt hold and AFC switches to off. This disables both altitude hold and automatic flight control modes, which will be covered in a later lesson.
Okay, so this is also off.
Set the rudder pedal shaker yaw switch to on. Rudder pedal shakers give an early warning of side slip at low speeds. The shaking pedal should be pushed to counteract the side slip.
Okay, rudder pedals in the opposition are on.
Set the landing light switch to off. There are 2 landing lights, a 250 watt filament for landing approaches and a 150 watt filament for hovering.
Alright, off.
Next, move to the landing gear flaps control panel and set the anti-skid switch to on. Anti-skid controls hydraulic pressure to the brakes and prevents skids above 16 knots and partial skid protection between 16 and 8 knots. Note that the anti-skid is inoperative while the parking brake is engaged.
Okay, it's on.
Check that the landing gear handle is in the down position.
Landing gear is in down position.
Check that there is no white band showing at the base of the landing gear emergency battery handle, which would indicate that the battery has been previously fired.
Okay.
Next, verify the flaps switches are set to auto and off. Off disables power to the flaps mode switch, and auto provides 25-degree flaps with the landing gear handle in the down position.
Okay, so flap position are auto and off. Correct.
At the lower left of the main instrument panel, ensure the water switch, labeled H2o, is in the center off position. This prevents water from being injected into the engine.
Alright, off.
Verify that the master arm switch is off.
Master arm switch off.
On the Armament Stores Management Control Indicator, ASMCI, verify that the selective jettison knob is set to safe, and the manual release control knob is set to norm. Safe prevents selective jettison of stores and suspension equipment.
Okay, safe and norm, correct.
Verify the IR cool switch is off. IR cool begins cooling infrared sensors and stores.
Okay. IR cool is off.
Ensure the multi-purpose color display, MPCD, is off. The MPCDs, often referred to as the digital display indicators or DDIs, are 5x5-inch CRT displays surrounded by 20 multifunction push buttons. These push buttons are numbered 1 through 20, beginning with the bottom button on the left side of the panel and counting upward in a clockwise direction. They are turned on and off with the brightness knobs located directly above them.
Okay, all of both
Set
of
the
them.
head-up display or HUD brightness knob as desired. The HUD is the primary attitude indicator, weapon status, and weapon delivery display. It displays collimated symbology and is electrically interfaced with the upfront control and HUD camera.
Alright, it has been turned to bright.
Set COM1 and COM2 volume by rotating the knobs to the 12 o'clock position and adjusting as necessary.
Alright, this is COM1. This is COM2.
Set UFC brightness as desired.
Full bright.
Verify the clock is set to the proper local time.
Alright.
Next, bring your attention to the miscellaneous control panel. This may be obscured behind the stick. Verify the FLIR switch is set as desired for the mission. For now, leave this switch in the off position.
Okay, so I have to move the stick and the stick and the FLIR is off.
Set the video recording system, or VRS, switches to the auto and HUD positions. Auto mode commands the mission computer to turn on the video recorder when air-to-air, AA, or air-to-ground, AG master modes are selected. HUD records the HUD camera.
Alright, so this is done.
Set the dual mode tracker, DMT switch as desired for the mission. The DMT allows the pilot to track a pixel contrast TV image, or coded laser energy, for target acquisition and attack runs. For now, we can leave the switch in the off position.
Fine, it's off.
Verify that the Inertial Navigation System, or INS mode selector knob is in the off position. The INS is coupled with the aircraft's GPS to provide accurate aircraft and targeting system coordinates for navigation and attack. The INS will be covered in more detail in a later tutorial. Ensure that the display computer, or DP switch, remains in the auto position. This switch controls selection of redundant display channels that drive the HUD and DDI. Auto is the default mode.
Alright,
Next,
done.
ensure that the mission computer, or MC switch, is also in the auto position. In the event of a mission computer failure, auto will allow the display computer to be used as an emergency backup.
Alright, this is done.
Finally, verify that the probe heat, PRB, switch is set to auto. This switch energizes the various probe sensors on the aircraft, and auto mode removes power from all heaters except the angle of attack case heater with weight on wheels. Once airborne, all probes will receive heat.
Alright, this is returned to auto.
Below the miscellaneous switch panel, verify that all circuit breakers are in the in positions. There are 7 circuit breakers controlling aileron trim, stabilator trim, rudder servo, flaps, speed brake, landing gear, and the right probe heat.
Alright, there. And position.
Now draw your attention to the electronic countermeasures panel on the right front dash. These switches control radar warning receiver, expendable modes, and electronic countermeasures, and will be covered in detail in a later lesson. For now, leave these switches in the off position.
No, but I'll turn this on, radar warning receiver.
Let's move on to the right console now. On the electrical panel, verify that the battery switch is set to off. The battery switch powers the ground service, switched battery, jettison, alert, and emergency 28-volt DC buses with generators and transformer rectifiers offline.
Alright,
Set the generator switch to gen. The main generator is an engine-driven, 30,000 volt ampere, variable speed, constant frequency generator which provides 115/200 volt, 3-phase, 400 Hz AC current to the aircraft main and essential AC buses, and to both the main and standby transformer rectifier units, or TRUs. In this setting, the aircraft generator will automatically come online when the engine reaches approximately 23% RPM. Failure to set this switch may result in a dual DEX failure during engine start.
Alright, this is in gen position.
Next, set the VHF, UHF radio remote control on the Auxiliary Communication, Navigation, Identification Panel, or ACNIP, to transmit/receive, or TR.
Trans. Okay, done.
Configure the rest of the ACNIP to suit your assigned mission. At a minimum, verify that the mode switch is set to the upfront control, or UFC, to set primary control of your ARC-210 radios to the UFC, and verify that the identification friend or foe switches are set to norm.
Done.
On the internal lights panel, set the compass, instrument console, flood, and warning caution lights knobs as desired to suit the environmental conditions.
Alright, I have to turn this.
Now, on the environmental control, or ECS panel, set the temperature controller to auto. This electronically regulates the cabin temperature.
Okay, I set this to
Verify
auto.
the equipment bay cool switch is set to on. This sends bleed air, or ram air-cooled heat exchanger, to the aft equipment bay housing most of the aircraft's avionics equipment.
Okay, this is on.
Verify the defog switch is in the norm position. This diverts a portion of the cockpit airflow away from the pilot to the windshield defog ducts.
Okay, this is not functional, but still not.
Finally, verify that the cabin pressure switch is also in the norm position. This opens the cabin pressure regulator and discharge valve on the forward cabin bulkhead, maintaining a constant cockpit pressure altitude of 8,000 feet, at altitudes between 8,000 and 23,000 feet, and a constant 5 psi pressure differential greater than ambient pressure above 23,000 feet.
Alright, this is in normal position.
That covers the after entering cockpit checklist and cockpit familiarization tutorial. You may now continue to the cold start part of the training.
Okay, so this was my cockpit checklist training procedure. So I finished with this. Now I'll be in the next video, I'll be starting this baby ASAP.